Okay, number 12. The diagonal of a square has length 10 centimeters. In other words, when you draw this picture, it's a square, even if mine doesn't look very square. That's going to tell us a lot in just a second. Okay. I'm going to cut the square. Oh, nothing. Gosh, this is hard.
Okay.
Okay, there's a straight line. Isn't it beautiful? Look at that. There we go. Okay, so the idea is, I don't care which side you look at. Here, let's look at this on the bottom. The idea is a square has a square before I cut it has how many 90-degree angles? 4. Oh, if I cut 90 in half, what kind of angles am I looking at here? What's this one? What's half of 90?
45.
It's not that. 45? Kind of important. That sounds really familiar to something we just talked about. Because if I have a triangle with 2 45s, what's the relationship again? Isosceles, or let's see. Oh, it's this one where we know whatever these lengths are, that longer one, the hypotenuse is square root of 2 times whatever the legs are, right? Let's remember that as we do this. I'm going to draw it bigger so you can see it since my other stuff's kind of clammed up over here. What do we know? We know one measurement. What's that 10? The diagonal, this part right here?
Yeah.
So if I draw this here, I can label that 10, right? I think it's centimeters. 10 centimeters. Okay. Again, remembering there's a 45-degree angle and a 45-degree angle. That's important to us because I know that relative to those other ones, this is like the square root of 2 times a, right? Remember from the formula we were just looking at? That's the relationship. If I can solve for that a, I'll know the measures of my other 2 sides. So that's how I'm going to use that. In other words, let's write it down here in a way that looks a little prettier. Square root of 2 times a. And honestly, they're putting a before. I don't really care which way you do it. It's equal to 10. Okay, help me get a alone. What should I do? Now be careful here. I'm not going to. Actually, we could square. Let's see. Oh, I was thinking divide it. That's what I would have thinking. Could you have squared it here? Yes, you could have squared it, but in the very end, you would have to square root it again. But yes, that strategy would still work. Okay. Now, when I look at the problem, what I personally think is get a alone. So yours is not wrong. I think you would still get there. It might just take a couple more steps. Okay. But what I'm going to do is say to get a alone, I'm going to divide by square root of 2. If I do it on one side, I have to do it to the other side, which is why, Brandon, your strategy would have worked. As long as you're being consistent on both sides, you're keeping it safe. You just might have an extra step at the end. So we have something like this. Now, hey guys, do I usually leave my answer with the square root number in the bottom, like that? No. We've practiced forever now clearing that out. It's a regular square root, so I can just times it by square root of 2, right? Remember when it was cubes and fourths and stuff, we had to think a little bit harder? Remember that? But here, this is a pretty straight one. That right there is going to give me 2 on the bottom. In other words, 10 square root 2 divided by 2. Can I simplify that more? What is 2 divided by, or 10 divided by 2? Okay, we've got it. 5 square root of 2. And if you want to approximate it, I guess you could. Your study sheet did not. It doesn't say to give exact answers, so that's kind of questionable there. But I guess that's just a little bit more accurate. And it's still in centimeters.
So that's not. So you don't times it when you rationalize the denominator or whatever you call it. You don't times it by negative. the square root of negative square root of 6?
Well, timing it by a negative would not change anything, honestly. If you forget and do that, you're safe.
Yeah.
Because the negative on top and bottom will just cancel, okay?
That's what, yeah.
But when it's just a single piece, no, we don't have to. We just times it by the same thing. The time that we change the sign in the middle is when you have two, like, terms, two pieces. And that's when you do it like over there.
Alright.
Brandon, did you catch that? When you have something like square root of 2, square root of 2, if you forget whether it's okay to use negative or positive, nobody cares. You can put negative on top and bottom all day long, it won't change it. But honestly, you don't have to. This is not conjugates because it's just a single piece. The easiest way to get your answer is just to times by the same thing on top and bottom. The same thing that you've got over here on the left. But that's square root of 2. Because it's just one piece. You see that? Versus back before, if you had like 3 plus square root of 2, you might have cared about the conjugate being 3 minus square root of 2. So there's a difference there. When you had two pieces, you would multiply by the conjugate, that kind of special opposite we were talking about. Here, when it's just one piece, literally you're just caring about canceling that bar. You don't have to do anything fancy here. That's something cool from the past, but right here this is actually easier. Makes sense?
Yeah. So it says, find the length of the side of the square, that's what the A is.
Yep.
So they already go ahead and plug it in for you, they know what they're trying to do. And so like, remember they came up with the
Yeah.
hypotenuse is equal to square root of 2 times A is already stands for the side, they already knows what you're looking for.
Absolutely. Yeah. That's why they set it up like that. I mean, I guess they could have tried to trick you a little bit, but really, maybe tried to make you blend together something else you know, but I don't expect too much trickery here. This was the main idea. So they would refer to. Skate park jump has a ramp. Check that out. 6 feet long and 2 feet high. So we have a jump. Let's see. Did that really just happen? Across and then up. It's interesting how much trouble I have drawing on this thing. Okay, we said it was what, 6 feet? And then 2 feet?
This is 6 feet long, 2 feet high, so it's how long is the base? So I think the 6 feet
Oh,
is
whoops,
actually the diagonal.
Oh, you're right, you're right.
At first that's how I read it too, then I read base.
Because it's saying the ramp. That's the key word there. Thank you for catching that. When it's saying the ramp is that long, I guess it's what you was right here. And you're right. Probably the clarification is because it wants you to find this ramp. That's smart. I'll use an X. You can use whatever you want. Let's see. Honestly, guys, this one's the same. You could do this one easily with Pythagorean's theorem, I think. Do you see that? Brandon, you see it too? It's tempting to try to look at it and try to make it something else, but Pythagorean's always worked, pretty nice. Let's do it. So, 2 squared plus x squared, or whatever. If you label it with ABC, that's fine too, but, that's fine. Equals 6 squared. So I have what, 4 plus x squared equals 36. Tell me what to do, people.
Try 4.
So here I have x squared is equal to 32. Okay, this is just like 11. Basically, the words made it a little bit trickier. You did a good job of catching that. But as far as the square root goes, we're still going to remember that technically there's a plus or minus in front of the square root, but we're going to not include the negative in our answer because it doesn't make sense. You know what, I don't think there's anything perfect in there because there is a 4 in there. They left it on the answer key as that and then approximated it. What do you guys get your type in?
5.66.
And what are the units again on this answer?
Feet.
Okay. two more. 14 is so tricky in how it's worded. But if you read it very carefully and label what you got, let's see, what is 14 now? If you read it really carefully, you can kind of figure out what goes where. Somebody read that to me, please, so I don't have to read it.
Number of seconds T. The number of seconds T that it takes for an object to fall x meters when drawn down a velocity of 9.5 meters per second is given by the function.
I'll write the function. Okay, so we have t seconds. What else do we have here? Oh, it's going to fall how much? X.
Meters.
X meters. Oh, and you know what? It almost tricked me. That is not even funny. The most important thing in any problem, guys, is to remember to label what your letters stand for. Because when it gives you information, you'll know where to put it. It almost tricked me, and I just now realized it. Okay. T seconds, X meters. Now, this thing is set, this whole 9.5 meters per second, do not even stress out over that. That's kind of generic, okay? That's the velocity for the formula. We don't really care that much about that, okay? They're just throwing that extra stuff at us. In other words, that 9.5 is built in. It's already taken into consideration in my formula. So here I have this. Long stuff that I may have trouble writing. Hey, maybe I can put a little note thing. So the next part, Brandon, please read on.
A rock is thrown from the top of Turkey Bluff, 90 meters for him,
Okay.
above the Gasconade River at a velocity of 9.5 meters per second. After how many seconds will the rock hit the water?
That's where labeling this stuff is really important. What did they give us again? So given what?
It's 90.
There you go. That's the important part because we said that 9.5 meters per second was generic. That's in both of them because it's just part of the setup of the problem. But the new thing is given 90 meters. Now, guys, if you labeled your stuff at the beginning, you tell me 90 meters. What am I doing with that? Where does it go into my equation? Is it going to be what the equation is equal to, or is it going in for my x? Yeah, for x. Because and it even reiterates it when it tells me solve for how many seconds. In other words, solve for t. So we have t equals, and plug in your x. So this problem actually was mostly about not letting the words freak you out, wasn't it?
Mm-hmm.
So all we do is just label whatever it says. Like it'll give you seconds T and then X meters, and then just look for the second meters.
Yeah.
Or
That's
look
usually-
for the second.
Usually when you have a word problem, if it's not one where you have to draw a picture, if it's one where they give you a formula, and Brandon, you will appreciate this in 161 that you're taking next semester, that is going to be the trick to most of your problems. Identifying your units will get you through a lot of work in that class.
Because I would have freaked out when I saw this from assessment today.
A lot of people will freak out
I would have
because,
completely just skipped it on top.
yeah, but it's actually the easiest problem in the whole thing. I mean, type in and see what you get. And I think they're going to allow us to round.
3.425.
And they did it to tenths on the key, so we'll just say t equals. I personally like. Well, here we'll write it out slower. Here it's 3 point what 4 what?
4.2.
Actually, good for 3 if I'm gonna round.
Needs to be a 4.2.
No, if you said 425.
Yeah, but that's rounded from the 4, from the 77.4.
Oh, so it is 3.42,
Yeah, we had 2.
and that's seconds. Yep.